All right, there is a second way to do polynomial division. It's called synthetic division, and it's definitely faster. However, it doesn't work all the time. It can only work when you're dividing by x minus r. So like x minus a number, which could also be x plus a number, because that's the same as x minus a negative number, right? So if you are dividing by that type of form, a binomial that starts with an x and is plus or minus a number, then you can apply synthetic division. Okay. And synthetic division is really kind of a little bit weird. So once again, I'm going to show you, I'm going to do the same problem. I'm going to show you what synthetic division looks like, and then we will look at the words. So I see, first of all, that I am dividing by x minus r. X plus 2 is x minus minus 2. So this is my r in this particular problem. It always, similar to what we did with the vertex in parabolas, it looks like the opposite of the number that's being added or subtracted to x. So the first thing I'm going to do when I'm doing synthetic division is I'm going to put my r in a little box. Half box, I guess. And then I'm going to line up next to it the coefficients of the polynomial I'm dividing into, starting with in descending order. So starting with the highest power, the coefficients would be 2, -3, 4, and 5. And you basically want to make sure that if there was any missing term, you would put a 0 for its coefficient, just like a placeholder we talked about in the long division. So I wrote out my coefficients. I'm going to skip a line and draw a line, and then bring down the first coefficient. So it's kind of a weird setup, but here's the process. Now what you're going to do is you're going to multiply this number by the r, line it up into the next one, and add. Then take that number times the r, multiply it, put that number underneath here, and add. So let's try it. 2 times -2 is -4. Add -7. 2 times -2. I just said 2 times -2, even though I was clearly looking at -7. -7 times -2 is +14. Put it here and add. +18 times -2 is -36, and add. And once you've done this, this line of numbers is your coefficients and your remainder. So this will be your leading coefficient of the quotient, and you always start 1 power less than the highest power term or the degree of what you were dividing into. So since this was a power 3, I'm going to start with a power of 2. This would equal 2x squared minus 7x. I'm just using the next number as the next coefficient, go down by 1 power each time. So plus 18, which will have no x's, and then this is my remainder. And if you double check, that's the same answer we got by doing the polynomial long division. So this is definitely shorter. It's more efficient, but it can only be used in that situation where you're dividing by x plus or minus a number. So we're going to go ahead and just peek at what these instructions say. Write R to stand for the divisor. Check. Write the coefficients of the dividend. The dividend is the thing you're dividing into. To the right of R, coefficients of the dividend. Bring the lead coefficient down. Multiply the lead coefficient by R. Lead coefficient by R. Write the product in the next column under the next coefficient. Add the terms in the column. Multiply the result by R. Write the product in the next column under the coefficient. Repeat these steps. Right? Then use the bottom numbers to write the quotient. Start with 1 degree lower than your dividend. All right. So what I want you to do is actually take a minute. We've got a number, let's see, 3. We've got 3 division practice problems here. So you know the drill by now. I want you to go ahead and pause the video and work on these 3 problems. If you can use synthetic division, I would. It's faster. And then go ahead and start the video back up and check on your work. All right, taking a quick look. I see that I am dividing by something, by an x plus or x minus r in this case. So I can use synthetic division. My r would be 3. I line up my coefficients, no placeholders needed, and then practice the synthetic division. Bring down the first one, multiply, add, no remainder, so it goes in evenly. Looking at number 3, I'm just going to skip to 3 since it's a similar problem. It's also a synthetic division problem. I'm dividing by x minus 3, so this time my r is positive 3. And I line up my coefficients. Again, no placeholder needed. And bring down first one, multiply, and add. I also have a 0 remainder here, so this also goes in evenly. But for number 2, I was not able to use synthetic division because of that 3 in front of the x. It doesn't say ax minus r, it's just x minus r. So if I have a number in front of the x, I'm stuck using that long division process. So I set that up over here. And I've continued by taking 6x cubed divided by 3x, wrote the 2x squared up top, and then multiplied 2x squared by both 3x and negative 2. Change the signs and add. Down to 15x squared and bring down the next one. And then what is 15x squared divided by 3x? 5x. Multiply 5x by 3x plus 2. Change the signs and add. And one more time to do it, looking at 3x into negative 21x, writing that negative 7 up top, and then multiplying and adding. So I end up with a remainder of 1 in that case. So my final answer could be written like this: quotient plus remainder over divisor. Okay, good job on the dividing. We're going to need that for the next group of things we're going to learn.